Alrighty, today we are looking at a tutorial for making sort of a drone, or emulating a bit of a drone control inside Unreal, but so you can do some cinematic stuff, but without all that VR headset stuff. So if you don't have access to one, or waiting on one, I guess, like I'm using an Xbox controller, but you can also do this with just a keyboard as well. We got like lens and focus. There we go. No, come on, focus, come back. Focus, there we go. Focus and lens and, moving around, tilting the camera, just all those stuff. So you could produce some pretty good cinematic quality stuff just without the need for those VR headset stuff. So, yeah, that's what we're going to be looking at today. As I screw up. Practice is probably still required. Anyway, let's get started. Alrighty, so to start, we're just in a blank games project with starter content, just what I use every time. And so for plugins, you need to have the take recorder enabled, but we don't actually need any of the VR plugins enabled because we're not using any VR stuff. So you can just leave them off or by their default. Yeah, so the first thing we're going to do is set up inputs. So that's settings and then project settings, which I already got open here. And then input, there it is, under engine. So I already set them up, but this is what we're going to do. You can set this up with with keyboard as well if you'd like. So essentially we've got three buttons. So the lens zoom in, lens zoom out, and start stop the take recorder. So that I had just the bumper buttons on the Xbox controller, and the B because it's red and record. No better reason than that. For the axes mappings, I've got the thumbsticks, so just remember Y to the sky when it comes to up, down, left, right. So I was pretty confident this is how it went. However, I'm less confident now for some reason, but a mode 2, they're called a mode 2 aircraft remote control is throttle and rotation or yaw on one, and then pitch and bank on the other. I'm just staring at one that I have. Yes, that's correct. Alrighty. So that's what I've set up for the Xbox controller as well here. So we've got up and rotate on the left and forward and strafe on the right. But if you're used to mode 1 or just, I don't know, your favorite video game or something, then you can change it to something else. The last thing I've got is the focus, which is just an A button. That's under axis mapping, and that'll make more sense in a minute. And then I just remembered I'm missing 2, which is camera tilt up or just camera tilt. And so for this, we're going to go gamepad, and I want right and left trigger. Right trigger, and so we're actually going to do both. So these are analog inputs, so they have a 0 to 1, unlike a button which is 0 or 1. However, right, we do have to tell it to use the trigger axes for that to make sense. Left trigger axes, right trigger axes. Don't even know where it is. Right trigger axes, and then one of these values has to be inverted. I'm pretty sure it's right, like so. So that's all the action mappings we're going to be using. You can add more. There's plenty more on the Xbox controller that you can add to do all sorts of different things, like so. So to actually make our camera, what we're going to do is I'm going to delete the player start, and we're going to create a blueprint. And so we're going to choose pawn rather than actor or something else. So if you read, pawn is an actor that can be possessed and received input from a controller. What this essentially means is we won't have to do the enable input or the set view with blend in the blueprint when we want to use this one. I am going to call this one drone camera, like so, and open it up. So for our components, what we're going to need is I'm going to use arrows, just because they're essentially an empty. So drone, and then I'm going to use another one called tilt. And then the last thing in this stack is a cine camera. Ta-da! It looks exactly like that drone you have. Alrighty. Next, what we're going to do is we're just going to remove all of these, and we're going to start. So essentially, what we need to do is like the better movement tutorial. So we just go like input, all of these. So up, input axes right. No, it's called strafe. Strafe up and forward. Yep. Yeah, they can be in that order. I'm going to put that one there and that one there. And we're just going to be using, on our drone here, an add relative location. Relative rotate location. Location, not rotation. I'm going to split the struct pin, because the first one in this list is up. So so this pin is always running. It's like an event tick. And then we're simply going to be plugging that one into there. Location Z, and so just do because it's not quite the same for, I've got two ups. I need to rotate. There we go. So on the rotate, we want an add relative rotation, of the drone. But it's more or less the same thing. We're going to split it. What we want is we want it on the Z axes. So Y to the sky when it's X and Y. Most things it's Y is up, but then on 3D printers and in Unreal, Z is up, which is nice and annoying. Alrighty, so it's set up like our movement tutorial. So we've got the up axes. I'm going to comment all of these. Actually, I'm going to leave it for a second because they're going to get bigger. So we got up, we got rotate. So everything's add relative location except for the rotate. Strafe is using a right vector, and forward is using a forward vector. And we're just multiplying the axes value, which is going to obviously be 0 normally, and then going to increase to 1 or -1. And that's going to inform where we move. And make sure you're using an add relative location, not a set relative location. Otherwise it's going to jitter about back and forward, because it's going to be zeroing out all the other values. So what we're going to do is we're going to drag our camera in. I'm just going to spin it down so it's already looking at something more interesting. And then under the details panel of the drone, under auto possesses player, we just want player 0. Now when we hit OK or play, and we turn on the Xbox controller. Went to sleep. There we go. There we go. So we can spin around. We can move up, down, forward, and back, left. Aha, they're back front. I did get it wrong. That's a shame. Project settings, inputs. Oh no, it's this one that's back to front. What do I want? Forward, rotate. Strafe has to be -1. That's weird. I guess the Xbox is positive in the left direction instead of the right. Anyway. Oh well, that works. Alright, so this is... I mean, we're sort of flying around, but it's a bit, yeah. Or meh, I should say. Not yeah. I'm not a fan. Like, you can't... I mean, okay, you can get cinematic stuff with it, but it's a bit difficult. And it definitely doesn't feel like a drone. So we're going to add some improvements here. So this was not in the movement tutorial, and what these improvements will do is if you're not using an Xbox controller, if you're just using a keyboard and mouse, or a keyboard, this is also going to produce a nice smooth result instead of sort of at least with the Xbox, you're sort of going 0 to 1 with the key. It's just like you're immediately going full speed. And so what we're going to need to do for that is we're going to need to create some variables. Now, in my original setup, I did not put this on the... what didn't I put it on? Oh, the axis tilt. Okay, yeah. Haven't even set that up yet. So, let's add some variables. So we just need to go current, spelled somewhat correctly. Current straight, just current everything we have, current. And why is that so small? They all need to be floats. So current strafe, current forward, current rotate, and current up. Like so. Next, what we need to do is we need to determine our speed of everything. So for our axis value, we're going to drag out and do multiply by another float. And we're going to use this value. I'm going to put that one up here and that one down here. So obviously this is like a percentage, so 1 is going to be 100%. So I want the forward and back to actually be a bit quicker, so I'm going to go 2, which is going to be double. The strafe I'm going to leave as is, and the rotate I actually want to slow right down. Yeah, rotate, yeah, I did already. Rotate, I want to slow right down to 25%, which will be 0.25. Like that. Next, we're going to be using a, not a lerp, because lerp doesn't, well, that's a vector lerp, but a float lerp doesn't work properly with this. I'm not 100% sure why, but that's okay, because we're going to instead use an f interp. Interp 2, which is going to be pretty much the same. There's our axis up. Wonder where that went off to. And so we're just going to use it on all of them. So what we're going to do is we're going to plug this in as our target. So in the case of the forward value, we're going to get the current forward one and plug that in as the current. This is going to plug in to our times. We're going to get the delta world seconds, get world delta seconds into the delta time. Whoops. And lastly, the interp speed. So for the forward axes, I went, if I check my notes, I went at a speed of 2. Oops, 2. Like so. Oh, and then the last thing is we need to, so this is using forward, so we need to then set the forward at the very end, and we want to set it to this value that comes out of the f interp. Like so. So now, if we give that a try, as I move forward, it takes a split second to speed up, and then when I let go of it, it sort of, as you can see, it sort of floats to a stop, a bit more like a drone. Not perfect, but you could fiddle with the values if you want, but it's a lot easier to get smoother movements, in my opinion, than that. Oh, with this. And then if you're using a mouse and keyboard, that's going to get you a nice, smooth slow down and speed up, even though you can't because they're a digital input, not an analog input. I guess. I mean, technically, I guess with the PS2 connector. Anyway, so we're just going to copy that exact setup to all of them, which I will do now. Alrighty, so I've just added them all to the others. So I did 2 for the interp speed for the forward and strafe. I did 4 for the up and rotate. I found those to be nice values. Technically, when it comes to a drone at least, like the up value, it shouldn't have any smoothness, when you're going up to stop, there should be no smoothness there because of gravity, but then coming down to stop, there should be. But did I hook something wrong up to the up? Oh, okay. So, yeah, I missed a step on the up. So you'll notice you do actually move up, but at a ridiculous rate, and that's because we forgot to set the new value. So, current up. So if things are moving really slowly, then you may have forgotten something. Alrighty, here we go. There we go. Up, down, forward, back, left, right, and rotate. Perfect. Also makes sudden changes in direction a bit nicer, I find. Lastly, we're going to add tilt to the camera. So we had that as camera tilt. And again, we're going to reference the tilt component, not the drone component. And we're going to add a rotation, sorry, not rotation. We're going to split this, plug that into there, and we're going to go pitch. But first we are going to times it by something, because as is, it's going to be rather ridiculous. So yeah. I did it by 0.2. Again, you can change all these values, have a fiddle around, find what you like. But now, as I use the triggers, I prefer not to have the tilt on a smooth. I'm not sure why, but like, can get some nice, interesting. Oh, screwed it up at the end. Camera moves like so. Quite interesting. Alrighty, so the next thing I'm going to do is label all these. So we've got camera tilt. Alrighty, so after we have organized things, you'll notice that we had I guess I could tackle either one of these two things first. What I'm going to do is the focus. So we had sort of the camera, as you get closer, obviously because we're in a cine camera, you know, things are getting nice and out of focus. It's probably not what we want. So we're going to have a quick look at how to do autofocus. So I did do autofocus. I have done autofocus, and it's more or less the exact same from when I did it last time. So we're going to get the cine camera. We're going to squint at the notes because I wrote them so small. Yeah, figured. Like so, we're also going to get our focus. So if you remember, okay, so last time we did it, on an event tick. In my last tutorial for focus, which was probably a while ago, we did it off the event tick. Instead, I'm going to be using a button this time. And so I'm going to show you how to set it up with a button, because it's not actually as simple as you'd think. Essentially, what we want to do is we don't want an instant focus change, you know, like a snap, but we just want a gradual, you know, focus pull. The problem is if we hook it up to a regular button where it's an action pressed, it only sort of fires once, and so it can only be an instant. So that's why we're using it as an axis instead. And so what we're going to do is we're just going to grab a branch off of it, like so. We're going to take our axis value. So if you remember, this is on a button, so its possible values are 0 or 1 anyway. And we're going to go equal, yeah, float, and if it's equal to 1, then we're going to focus. And so that just means we can hold down the A button in our case, and then it'll gradually pull focus to whatever's in the front of the lens. Next, we're going to get the world transform of the cine camera. That's what this was doing down here. Pardon me. So world is better than relative in some cases. In this case, it is going to be better. Take my word for it, I guess. I've tried both. So like that, we are then going to get the forward vector from the rotation. like so. We're going to, on the true, so if we are focusing, we want a trace, a line channel trace by channel, line trace by channel, that's the, it's around here somewhere. So for our start location, we're just going to get the world transform location. For our end location, we are going to take the forward vector, we are going to multiply it by a float, and for this I'm going to go 500. The smaller this number, technically the better the performance, although with only one trace it shouldn't be that bad in the first place. And then what we are going to then do is, so that was a multiply, we are then going to plus the two vectors together, which is going to get us our end vector. We do want trace complex, so this means whether we trace for just the collision geometry or the physical geometry, and because collision geometry doesn't match physical geometry in most cases, that would give us an off focus, I guess. We can leave all these as is. On our hit event, we want to come out and we want to break the result, like so. We are then going to get camera focus settings. I think first we have to drag this cine camera out, get camera focus settings, like so. They split the struct pin. We are then going to go down here. We're going to use our buddy the F-interp too. So for current, we're going to go the focus distance here. For our target, we're going to go the distance here. And then we're going to get the world delta seconds for the delta time. And the interp speed, I had set as, where's my notes? 3. Again, have a fiddle with this value if you would like. Lastly, we're going to set the focus settings of the cine camera. Set focus settings like that. We are then going to drag off this and make the camera focus settings, and we are going to plug their new value into there. Oh, and then plug that into there so it actually does set. Come on, there. No, whoops. Like so. So what we're doing is we are emitting a beam. So when we press the focus button, we will be emitting a beam from our cine camera, like so, until it hits something. When we get what it hits, we're going to get that distance, and we're also going to get what our current focus is, and we're going to slowly smooth between the two, and set that as our new focus. So let's highlight all of that. So that's pretty much what my previous tutorial for focus did, minus the F-interp, and minus doing it on a button press or hold, button hold technically, like so. So now if we hit play, let's go down and we go nice in close, and then we hold the A button. There we go. It sort of went there. Whoops. I need to actually point at something. Pressing the wrong buttons here. Whoops. There we go. Now, focus is something I prefer to change in the sequencer. A HUD with a crosshair would probably be good for where it's actually hitting, but yeah, I do prefer to change the focus later in the sequencer, but if you just need a quick preview, then this works perfectly, like so. So the last thing we're going to be doing is the lens. Oh, and we're just going to add a quick, I might do that now. So we do have a start-stop recording for the take recorder. Start-stop, here it is. This one's really quick and easy, so we need a flip-flop off of it. Flip-flop, floop, floop, floop. So we press it once, it does A, press it again, it does B, press it again, it does A, switches between the two. We're going to drag off and go the open take recorder panel. So this gets the existing take recorder panel, and then we just type start recording. So there we go. Don't know why that didn't connect up automatically. So we just take our open take recorder panel and just essentially hit record. And then we're just going to type stop recording, which doesn't require reference to the... I think I typed start instead of stop. There you go. Like so. Alrighty, so the last thing on our list is the lens. So we're going to be doing almost the same as how I originally did it back in the, I think it was like a third tutorial I made, except this one, instead of just cycling through any old lens set, we're going to be going sort of back and forward through it, so you can zoom in or out through a set. We're not going to do zoom, so if you want to check the zoom tutorial for that instead. So we're going to start by making two variables. First is going to be an integer, and we're going to call this lens index. Back to the front, lens index. And then we're going to create another variable, and we're going to call this lens set. This one, however, we're going to make a float. And if we tick the little thing next to the float, we can change it to an array. And we compile it and save it, and it happens to, because this already existed, and I didn't compile between deleting it and re-adding it, it's already added the lens set there, but essentially compile it and then you can add some stuff into the array, and I just went through and added the sort of standard cine lens set I usually add to things like that. So next what we're going to do is we're going to go and add our lens up and lens down. Like that, and then we're going to add a branch off both of them immediately. Branch, whoops. So attempt to keep it neat. Next what we're going to do is grab our lens set and get a reference to it, and grab our lens index and get a reference to it. We're going to grab the last index from our lens set, and then we are also going to grab so what we're going to do in this is we're going to do two equals, equal like that, and equal like that. So so this will get the last index of our lens set. So on our lens set, the last one is actually 5. So if our current lens is equal to the last lens set, so our current index is equal to the last index, then we don't want it to go up again because we can't go up. And then if our current lens, this we don't actually want that plugged into the last index. If our current lens is equal to 0, so we're at the start, then we don't want it to go down any further or zoom out any further because there is none to zoom out to. So like that. Next, so if the current lens is equal to the last lens, so it is true, then what we want to do is we want to set our lens index to 0, so it starts back at the start. And exactly the same thing, more or less, so we want to set it. The only thing is here, if it is equal to the first lens, then we want to set it to the last lens, like that. If not, now for neatness, I'm just going to get these again, but you can just reuse the same one if you'd like. If it is not, then we will go ++, so we'll increment the integer up. So we'll go to the next. And this one, we're going to go -, and we're going to de-increment the integer, so we're going to go down one. Make sense? So we're starting by running a check to see if we're on the last or first lens. And if that is the case, we will loop back around. In either case, we will loop back around with these two sets at the top. If not, then we will progress to the next lens or progress to the previous lens. Alrighty. Lastly, we need to set the focal length. Yeah, drag off the cine camera and set focal length. Set current focal length like so. Now I'm going to get another, again you can just keep reusing the same one if you want. I'm going to get a reference to another one. And we need the lens set as well. And we're going to come off this and get a copy like so, using that index, and that is what we're going to set as the focal length. Now for the execution pin, I'm going to plug everything in. So no matter what happens, it will all set the focal length, like so. Pardon me. He keeps sneezing a lot, which is not a good thing given it is 2020, the bad half of 2020. Alrighty, that is our lens all done. Create a comment. Change lens like so. Compile, save. So now we hit play. So we can. My Xbox controller's gone to sleep again. Doesn't want to stay connected to PC for very long. I found that interesting. So we can go up, down, we can turn around, we can go forward, we can go back, we can focus. Yeah, there we go. And we can also zoom in and zoom out. Zoom in and zoom out. Focus. Zoom in, zoom out. So hopefully this is a bit interesting for those who maybe don't have access to the VR headset or anything to do some regular virtual production. You can still get some, I say as I struggle, there we go. Still get some nice cinematic shots, I think. Oops. In Unreal, I'm gonna nail this. Wait, back. Obviously, you still need good coordination. Here we go. I'm feeling good about this. You still need good coordination, but you can hopefully do something in Unreal despite maybe a lack of equipment. So, you know, an Xbox controller probably recommended for this over some of the other stuff, but even a mouse and keyboard, you know, you can do something.